uh, Pranav and all the friends, Sunil bhai. So we are very happy to welcome one and all of you for this talk. And today's focus area is technology. And technology is having far-reaching implication in our life. Like 20 years before, I would say internet was a new thing, and look at today, where internet is, we cannot live without internet, we cannot live without Google. So it creates a impact in your life which is different. Your life changes. So it's very important and interesting to know what's happening in technology. So technology trends such as artificial intelligence, cloud computing, autonomous vehicles, Internet of Things are new technology trends, and that is going to have very deep, far-reaching implications in our life. And this will change the way we live our life. This will change the way we teach our children. This will change the way we do our business. And hence, it is very important to know what's happening. Now, if you don't kind of ignore these technologies, then the implications will suddenly change your life. You won't know why it is happening. Your business will go haywire. You won't know why it is happening. But it is because of these technological changes which you need to know and update yourself. And at AMA, we have made it a point to invite global leaders, invite people who are involved with this technology research and are at the cutting edge of this technology across the world. And in that initiative, we have invited today Pranav Mehta. And Pranav is Vice President Intel Labs and Director of Systems and Software Research at Intel in USA. Pranav and I have known each other since childhood. We went to CN school together. He was 1 year junior, and Pranav's sister Neelam, we were in the same class. So after completing school, he did his engineering at LD Engineering and then did masters at Virginia Tech. And then since last 30 years, he has been with Intel. So it's a first and maybe last employer for him. So in his long association with Intel, Pranav has held several senior technical positions, mainly with Intel's embedded and communications infrastructure business units. And starting as a software engineer, he led several embedded chip architecture definitions earlier in his career before moving to system architecture definition and development. As Intel's chief NFV architect, he was one of the founding members of ONF, open source project of Linux Foundation, which is the first open source telecommunication project with global participation. Pranav is Vice President in the Technology, System Architecture and Client Group and Director of System and Software Research, part of Intel Labs at Intel Corporation. The System and Software Research Lab explores emerging usage models and workloads like artificial intelligence, autonomous system, ambient computing, visual cloud, cloudification of network infrastructure, and more. And this will accelerate the computing and communication ecosystem. That's what Intel is having expertise in. The goal of the lab is to comprehend their implication on the underlying system software layers as well as Intel platforms to ensure they are best optimized to create most satisfying end user experience. So this is the technology side of Pranav, what he has been doing all these years. And on his personal side, he is a very good singer. I've been hearing him since CN, and before 2 years, we were in Phoenix, and I had an opportunity again to listen to him. He sings Gujarati Sugam Sangeet songs and filmy songs in the voice of Mukesh very well, so that's his personal side. And so I'm very happy to invite him for his talk, and we are very happy at AMA we could get a technology expert like him to give more focus to on the technological reforms which is going on in the world. Pranav.
Thank you so much. Good evening. So first and foremost, I must say it is my privilege to be here in front of all of you in an institution that since I was very young, I always knew about because my uncle was part of ATIRA and that whole Vikram Sarabhai group. So I'm really delighted that I'm able to come here and share some of my views on technology and some of its implications for society here today. Thank you, Mr. Nair and Chirag and AMA team for inviting me. As Chirag said, I grew up in Ahmedabad for first 22 years of my life. And then for last almost 31 years, we have been settled in Arizona in US, where I have been working for Intel. As he said, it's my first and only job, and hopefully the last job I will have. One question that always comes is, the field of technology is so broad. So anytime somebody tries to say, especially give this kind of title, that technology trends and societal implications, I want to caution you that I'm not here to boil the ocean and give you the most comprehensive view of technology and all its implications. My view obviously is going to be limited by what Intel does and the kind of things that I have been part of. So please keep that in mind. It is one of the perspectives that you will get here today. One unique thing about Intel that I will share is the fact that Intel is not only a technology leader, but it has a unique position in the digital economy in general, because Intel is a building block supplier. We don't do the entire product by ourselves. We actually supply the relevant building blocks so that other people can actually put their value add on top of our own building blocks, integrate them together, and then deliver it to the customers. So we do have a unique perspective because we kind of work with many, many different ecosystem partners in the industry to make sure that our building blocks can satisfy their needs. So that is one unique perspective we have. The other important piece that has appealed to me very much, and that's why probably I have stayed at Intel for all these years, is this notion of open platforms. As a building block supplier, many, many years ago, Intel management decided that we were going to create our building blocks in a fashion so that we have open platforms where different people, even some of our competitors, can add their components to our platforms very easily and create something that is bigger, better, faster than what we could have done by ourselves. So that philosophy, what it really does is it tries to grow the overall pie rather than keep the pie fixed and then everybody tries to fight for their own piece of the pie. So we believe in creating a growing economy and growing ecosystem rather than just kind of look at everything from a competitive standpoint. And lastly, even though most people would associate Intel with the chips that we supply, or the hardware that we supply for the computers or for the data center servers, etc., Intel invests tremendous amount of funding for what we call the experiences. Because as a building block supplier, we just don't want to develop these building blocks to guess that, okay, we will do this and somebody will be able to use it in this fashion. We actually want to build out the entire stack ourselves, understand what kind of experiences can be realized using our building blocks, and then work with ecosystem partners, and some of them take ideas from us to really take it to the market. So we have investment all the way to the top level of the system and application software, and that's where my research lab comes into play, because systems and software research, we operate at some of those higher levels of abstraction rather than just in the hardware. So from an Intel Labs perspective, Intel has essentially two main research efforts. One is on the components research side, which is where, as I said, we basically make chips, silicon products. And we have a huge organization within Intel that really innovates around how to make those chips better, faster, cheaper, less power consuming, et cetera, over generation from generation. That is our component research team. And then Intel Labs is really focused on the product side of it. So they make the chips better, and then we try to make the products around that chip technology in a better fashion. So all the microprocessors and different types of chipsets and networking gear, all those things, improving them is part of the Intel Labs. And that is where one of the things we always say that as Intel Labs, we try to help Intel predict the future as to where the computing industry is going in future, so that we can prepare ourselves better and we can build the right building blocks for that future economy. And one of the biggest things that we do as part of that is university research. Intel Labs is the institution that really establishes alliances with the best academic institutions, not just in US, but all over the world, to make sure that we can harvest a lot of that creativity that we have in the best academia, where you have best students, best faculty, they come up with all these new innovations. We work with them and we harvest a lot of those ideas into our product thinking. So when you say that we try to predict the future for Intel, how do you predict future? An author by the name William Gibson in 2003, he had this quote that the future is already here. It is just that it is unevenly distributed. Meaning, and there is an example here that this is the scene 16 years ago at a train station in Tokyo. Do you see anything similar that happens today? Everybody kind of nurturing their smartphones. This was 16 years ago. Now, you could say that if somebody was paying attention to what was happening in that small sliver of the world, they could have predicted what the future was going to be, where everyone was going to have one of these things, and all people were going to do was to nurture their smartphones individually, rather than the typical scenario that you see at a train station probably 16 years ago in India, where everybody's kind of just talking to each other, rushing to the train as a group rather than having this kind of individualistic persona. So future many times is right among ourselves. There are patterns that you can spot today. It is just that it has not yet become universal. So that's where we kind of, as part of Intel Labs, we try out a lot of different things. We try to spot these things and try to see if we can scale them and then what kind of issues we may run into. Now, some of those ideas may not go anywhere because even though it may seem interesting in that instant, it doesn't scale very well. But some ideas may actually lead to what we would call future at some point in time. One such example that you can see today is that there are lots of websites and companies that have sprung up who do your DNA analysis. Now that genome sequencing has become more accessible, people do a lot of DNA sequencing to find your family tree and those kind of things, your history, whether you have this kind of race or that kind of race. Those type of things are already beginning to happen. And we also have seen that in some limited health-related scenarios, like oncology, people have used this kind of genome sequencing very successfully for preventing breast cancer or prostate cancer and those kind of things. However, that has not yet proliferated to a wider swath of healthcare. But we believe that it could be that in future you would have that same kind of technology to predict these type of biomarkers that will predict some of the health issues you may run into in future. Or even within diseases, you have the subtypes so that you can prescribe more individualistic medicines to your patients, or gene therapy, or new drug discovery, depending on how different patients may react to different things. So these are the kind of things that we believe could happen. Now, of course, as I said, from that idea that looks promising to something like this, where it will become a full-fledged thing, there are a lot of challenges that we will have to solve, and I'll talk about some of them as we move forward. But that's the kind of path that this kind of technology usually takes, and usually takes a decade or 15 years or sometimes even more than that. So Chirag actually talked about some of the technology trends that we have seen in the last few decades. Internet was the big thing that happened in the 1990s. Mobility was the big trend that happened in the 2000s, I would say, where essentially you were able to get rid of all the wires from your life, whether it was for laptops, you had the Wi-Fi, and you were able to get rid of the Ethernet, or for cell phones, they became very prevalent. And of course, in the last decade, it has been the decade of smartphones and cloud. And there was this famous saying that Steve Jobs had, which was, there is an app for it. So everything that you wanted to do had an app. And the way that app worked was, it was not actually everything that was done on your smartphone. The app essentially had a back end in the cloud, and between your smartphone and the cloud, they work together to deliver you all these amazing experiences. So what are some of the trends that are happening, that we are going through right now, in last few years, I would say. From our standpoint, there are two big things that are happening. One is the Internet of Things. So if in the 2000s and maybe the early part of 2010s, if people were getting connected with each other in a very rich fashion, where you could share your videos and you could share your pictures and all kinds of graphical images and things like that. What has happened is now what we call the things around us, whether it is a factory machine on a factory floor, or whether it is equipment in a hospital, or whether it is your automobile, or it is many of the traffic infrastructure, etc. All these different things, and some people would even say that at some point your toaster may get connected to internet as well. So these are the kind of things that are getting connected to internet. And once you get connected to the internet, that device becomes accessible through the cloud, through the internet protocols, and you could do some amazing things with it, assuming that you have the right kind of provisioning and management infrastructure built around it. So Internet of Things is one of those big trends. And then the other big trend is what's initially started out as machine learning, then people called it deep learning, and then, of course, nobody wants to use somebody else's term, so people came up with yet another term called artificial intelligence. But fundamentally, all these different things, what they are trying to do is they are trying to feed tremendous amount of data to machines, and we have come up with these new ways of designing these machines through what they call the convolutional neural networks, or CNNs, so that essentially you feed these machines lots and lots of data. These neural networks operate on that data, they produce an output, and then you tell the neural network whether the output was right or wrong, and then it goes back. If the answer was wrong, it goes back. You keep feeding it data, it will readjust itself until it produces the right data. And amazingly, if you do this enough times, at some point that machine learns enough about your input data so that now you feed it a new piece of data and it can still figure out what the correct output was. So you must have seen lots of people talk about it. In fact, there are publications after publications that talk about whether a machine can detect a dog or a cat. So the idea was to feed thousands and thousands of images to these machines, and every time the machine will say whether that picture was a dog or cat. And if it predicted wrong, you say, go back, your answer was wrong. It will readjust itself and then try it again. And after a while, it will start predicting whether it was a dog or a cat in a very reliable fashion. Now, the most amazing thing about this machine learning technique is nobody knows why it works. Just kind of like our brain. And that is where, in my mind, lies the biggest potential and the biggest vulnerability for this technology. Because if you cannot really understand why something gives you the right answer, can you really trust it? And that is where a lot of research is going right now where some people are calling it, using the term explainable AI, so that you should be able to explain why things work the way they work. Up to this point, with a lot of this image classification where you are trying to detect from lots of whether graphics images or video images, you are trying to figure out whether there was somebody, a human being in the picture or not, or whether there was a red car in the picture or not. All these different classifying jobs or classification jobs. We know that these neural networks do an amazing job of detecting those things. We just don't know the theoretical basis for it. And that is where there is potential. I'll talk about how that could be a very serious problem if we don't really get to the bottom of it. The fundamental thing about these two trends is that having a lot of things connected to internet allows us to sense things, because these are things that are out there in the physical world, whether it was a video surveillance camera or whether it was a temperature sensor or a pressure sensor somewhere, or a microphone input from one of the microphones. There are lots of different sensors and sensing data that are now available to us because these things are now connected to internet. And then there is the sense-making aspect, which is where the AI comes into play, where you really try to figure out what is happening in the world and make sense out of it. So this is the kind of current big trend that is going on. What I want to use as two examples, and I think Chirag mentioned this as well, autonomous driving is the classic case. It is probably the most extreme case of these sensors, this Internet of Things, as well as artificial intelligence coming together, because now you are essentially saying that a car should be able to drive itself. Now, I still suspect that people who talk about autonomous driving, they probably have not been to Ahmedabad. And I can say that that's a pipe dream. Means if somebody can navigate the traffic in this city or any of the cities, big cities in India, if a car can drive autonomously on its own, I don't know if I would still be alive to see that, but I would hope so. But the goal is to really bring all these pieces together so that the car can have multiple sensors, not just the cameras and radars and lidars, but it also has a very sophisticated communication capability so that it can not only detect things on its own, but rely on the infrastructure in the middle to complement whatever the sensing it is doing on its own, and then rely on that, and then also, of course, on the cloud for many of the training data to really make sense out of the environment around it. The one thing that I would like to point out in all these things, and as I said earlier, artificial intelligence as a concept relies on tremendous amount of data. The more data you have, the better accuracy you get with your system. The question becomes an economical one as well, that where are you going to store all this data? And how are you going to move all this data to the appropriate place where you are going to process it? So an autonomous car, as you can see here, by itself, one single car produces 10 terabytes of data per day. For those who are not into the technical lingo, a terabyte is 10 to the power 12. So that amount of data, tens of them, one car produces. Now, you all have, I know that Geo gives free data things, but I think there has to be a limit on it, right? You may have some gigabytes or something. 2 GB? 2 GB per day. Okay, so 2 GB per day. 1 terabyte is 1 billion GB, right? So 1 terabyte is 1 billion GB, and that is just one car. So imagine the kind of, means this would drive all the geos and all the carriers in the world into ground, because they cannot sustain this kind of data rate. So there has to be something done differently for these things to work. And there is no way to avoid it, because as I said, artificial intelligence requires data. If you don't have lots of data, you are not going to get the accuracy that you need. So that's the kind of dichotomy that gets introduced with this particular trend. The other use case I mentioned earlier is this notion of omics. We all have heard probably the term genomics. And by the way, I'm not a doctor. I have a couple of my best friends who are doctors, so I will leave it up to them. But omics is a term that they came up with, which is all these different studies of molecular biology. Genomics, transcriptomics, proteomics, biomics, microbiomics, all these things are trying to understand the living organisms that are within us and that affect our health. So when you try to understand and apply this artificial intelligence field to healthcare, you can imagine that one human genome, it's about 20,000 different genes, and that's about half a terabyte of data. But that is just what is in your own genes, right? We all know that in our gut, we have millions of different types of bacteria, what they call the microbiomes, that impact our health as well. So one's health is not just about what gene you were born with, it is also about all these other living organisms that affect your health. So if you really want to get a comprehensive view of someone's health, you have to understand and dissect all these different pieces of information. And that would just, again, create a tremendous amount of data that you have to figure out how you are going to deal with. And what we are trying to do, in fact, working with Indian government, Intel is right now in the process of putting together what we call a research center, an AI research center for health at a population scale. So we want to study these problems. As I said, that when you have terabytes of data per person, maybe you can study thousands of people in a small study and you can derive some conclusions. But if you really want to understand this problem to see if it will become future or not, you have to study these problems at population scale, billions of people. So that is where we are working with Indian government to see if we can have an omics-focused AI center to really study how you can bring these different types of omics data into one integrated fashion along with all the other healthcare data that someone may have. Their history, their x-rays, their CT scans, all these data, they are all in different places. How do you integrate all of them together to really predict what is going to happen for somebody's health? So these are the kind of challenges that we are seeing, and hopefully we can start understanding them to see if this indeed will be our future or not. So I talked about the data. As you can see here, the data has been growing exponentially. In fact, you will be surprised to realize that in last 10 years, so computers have been around for a long, long time, right? I just talked about even internet, which was the first big explosion of computers and data across the world. That happened in the 90s, but computers were around even before that. In last 10 years, the amount of data that has been generated is 8,000 times more than what was generated before. And if you just take last 15 years, it is 800 million times more than what was generated before. So the explosion of data is just going there. By the way, you see the term 4.4 ZB, that is zettabytes. I talked about terabytes as 10 to the power 12. Zettabyte, anybody knows what zettabyte means? 10 to the 18 is exabyte. Zettabyte is 10 to the 21. So if terabyte scares you, zettabyte should scare the heck out of everybody. So this is the kind of data that is going to be generated, and somehow we have to figure out how to move it to the right place, how to store it, and how to process it. The other big thing that is happening with this data creation is that if you look at the early part of this evolution, what you used to see is that there was a lot of data that was around productivity. People were using computers for office and all the kind of productivity tools. Then, in the last 15 years, broadcast media started happening. People were streaming stuff on internet, and that is what took over the majority of the data. But now, for last several years, there is an inversion of data. So up to that point, the cloud or the servers used to feed the clients with a lot of video-centric data, a lot of rich data, whereas the clients themselves were not feeding the network with as much data. Now what you can see here is the client-generated media. How many of you load videos on YouTube and WhatsApp and every day? There are staggering numbers, millions of YouTube videos that get uploaded daily. So this is what is going from the clients into the network, not just somebody streaming particular sports event or something from the cloud to the client. So this is where what we need to recognize is that the entire infrastructure that has been set up for all these years is going to go through a significant recalibration, if you will. So if you look at the current paradigm that exists, you have your client devices. On the other hand, you have your cloud, or what the historical term was the servers. And then in between, you had what was called the infrastructure or the network. This paradigm was set up where clients would simply send few commands through the network, and then the cloud would compute all the requests, and then depending on it, it will send the data back to the client. And that data, in many cases, would be a lot more than what the client request was. So the infrastructures were really set up for that kind of paradigm. I just talked about the data inversion, where now the clients are trying to feed tremendous amount of data into the network. So this is going to fundamentally change how we think of clouds or the cloud computing. As you can see here, we always looked at cloud as something that was out there, and literally it is out there because it is sitting behind that network, and you are going to rely on the clouds in that fashion. But with all these new Internet of Things and everything happening, the question becomes, can the cloud really stay there and still be useful for a lot of these new usages that are emerging? Or it needs to be down here, just around us, so that we can touch it and feel it, and it is palpably close to us, so that you could actually get the same benefits of the cloud, where it has a lot of compute power and it can do a lot of cool things for you, but it's not far out there. It is kind of just around you. And this is where one of the newest trends that is happening is called the edge. And I would call it the evolving edge. And the notion is that people are trying to figure out how to merge that network infrastructure and the cloud so that you create a continuum where the cloud is kind of just like around you. And this picture tries to illustrate that in some fashion, where you can see that all the clients, who are creating the data and also consuming the data, they have a resource that is kind of closer to them rather than all the way back here behind the infrastructure. And then you would figure out dynamically how to partition the resources between what is cloud and what is the edge. And this edge is becoming one of the latest, I would say, battleground for many, many players in the industry, because people like Google and Yahoo and Microsoft and Amazon who own the cloud, or you have Alibaba and those kind of people in this side of the world. And then you have all the telco carriers, the Geos and those guys in India, the China Mobile in China, or AT&T, Vodafone, all those people in some of the Western countries. They are all trying to now figure out how to stake their claim to this evolving edge. And frankly, nobody knows who is going to win, because this edge is in many ways like an infrastructure, which the cloud guys don't know how to do that. And in many ways, it is like cloud, which most of the telcos don't know how to operate. So it is going to be a battleground, and that's where we would like to believe that we can play a role in helping sort out these problems, because we are neutral. We are, as I said, we are a building block supplier. We want to make sure that our building blocks can support this emerging notion of edge in a meaningful fashion. Now, the interesting thing is, however this edge comes about, there are 4 fundamental things that it needs to deliver. It needs to deliver latency. If people are playing cloud games, that's the new latest trend of cloud gaming. You are clicking your mouse and you want to see the reaction. Pardon my saying this, but for some reason, people like to kill a lot of people in these games. They just kind of shoot incessantly, and somehow it's an adrenaline rush to just destroy things. Well, if you click something to destroy something, you want to see the result right away. You cannot have the latency of going all the way across the network and the cloud processes it and then shows the result on your screen. So latency is going to be very important. Bandwidth is going to be very important because, again, you are transferring very rich content back and forth. Security is one of the foundational things. We haven't yet talked about security at all in this whole conversation. I'm going to come to it. And if that doesn't scare people, I don't know what will. Because if people are concerned about privacy and security, I think this is going to be one of the big areas of focus. Because as the edge comes closer to you, it may now have access to your data that in the past it didn't. So you also need to be aware of some of the security vulnerabilities that you are opening yourself up to. And then, of course, connectivity is always there whenever you talk about networking. So one of the things in my lab that we are looking at is this notion of visual cloud. The visual cloud term is basically, it means processing of video data at scale. So you want to do, whether it is video surveillance or it is augmented reality or virtual reality type games and sporting events that you want to see, all these things where you are processing lots and lots of video data and trying to process it and then deliver it to the clients in a very, very short amount of time so that you maintain that kind of real-time feel to it. That is going to be one of our big research areas. And as you can see, there are a lot of these use cases like media analytics. People want to figure out if you have lots of video surveillance data, you want to just figure out if somebody walked in or not. Or for crime prevention, people are looking for a particular vehicle at a particular time. In the archives of videos, that is thousands, hundreds of thousands of hours. How do you find that needle in the haystack kind of thing? So these are some of the emerging technology trends that we are looking at. As I mentioned, there are some significant challenges. Scalability was one thing I already mentioned. But there are 2 big challenges that I think we as an industry need to work together to solve, because these are not minor issues. The first and foremost is the power and energy. This would scare a lot of people. World's data centers. And by the way, I was fortunate enough to visit one of Facebook's data centers a couple of years ago. And it is an amazing thing. It is actually several football fields you can fit within that data center. And it is just rows after rows after rows of high-end servers that are just managed, and you don't see a single soul in the entire building. It is all automated and managed by few people who are running that data center. But those data centers around the world that are owned by these big companies like Google, Facebook, Amazon, Microsoft, Alibaba, Tencent, they are consuming 1/5 of Earth's power. They will do that by 2025. Imagine that. Where are we going to, if more and more data is generated, as I just told you, it has to be stored somewhere, and most likely it will be stored in these data centers as it is being done today. They will need a lot more power to operate those data centers because there will be more of them. And where are we going to get the energy to feed those data centers? So all this stuff has to become very energy efficient. Otherwise, none of these use cases will actually come about. The other big thing I mentioned was the security and privacy. There have been a lot of these cases that are getting reported where you can see here fooling Google's image recognition AI. Now, as I mentioned earlier, the artificial intelligence or deep learning use cases that we have today, they do an amazing job of recognizing objects in videos and graphics images. But you cannot explain it, why it does it. And that's where, as most engineers, we would say that if I cannot prove something, why it works this way, how do I make sure that somebody cannot spoof it, right? And that's where a lot of these things are going to be issues. Like machine learning masters the fingerprint to fool biometric system. And I'll give you some examples here. What do you see here? It's a traffic sign, right? What does it say? Stop. So if you have an autonomous car that is driving on the road, when your video camera senses this, it should say, this is a stop sign. I should stop here. You see those few stickers that somebody has put on them? This will, and this was a paper published, for a trained algorithm, it would read this particular stop sign as a sign that says, speed limit is 45 miles per hour. Imagine that. So your autonomous car, instead of stopping, says, I can go 45 miles per hour. That's scary. Another paper showed, and by the way, these are the examples of what we would call adversarial AI, where somebody is using these AI techniques to spoof the computer. Here, in the first row of images, you can see that there are pedestrians crossing, and your AI system is correctly predicting that there are people who are walking and you need to take appropriate action. By just manipulating that image that is going into the camera slightly, it seems like there is nobody on the road. And you can just go through. That's a very scary thought. Another one, this was a student that I have actually met at CMU, Carnegie Mellon University. That's a very funny one. They have, as I said, these machine learning algorithms can detect people very, very accurately. Well, what he did was he put on this particular type of glass frame, and this Chinese student gets recognized as Brad Pitt. So imagine that. You may think that now that the banking system has facial recognition and all these kind of things, they will recognize you correctly. I already talked about the fingerprint spoofing on the previous page. This can wreak havoc in people's lives if people are able to do these kind of things. And one of the reasons for this is also why there is a big push for this explainable AI is because of these type of cases. So the good news is everybody is becoming more aware of it, and people are trying to figure out how to circumvent these kind of issues. And the best way to do that is by having checks and balances, right? You need to have fallback and fault tolerance in your system so that you are not just relying on one piece of data to make your decisions. So before I end, I will just say this, and this is, I would not say that this is necessarily Intel's view, but this is probably my own personal concern about where technology has been going and what it could lead to. Let's suppose that we can make all these challenges, we can meet them successfully. We can create scalable and secure technologies that will do all these wonderful things that we talked about. But what about some of the other issues that pertain to societies and cultures? One of my biggest frustrations and disappointments with how the technology has evolved over the years is that we are becoming more of a homogeneous culture rather than retaining the heterogeneity that we had with our individual cultures in the global world. Now, I'm not suggesting that we go back to the old ways of things and somehow globalization and this internet and connectivity are going to disappear. But at the same time, in my view, if you think of this kind of distributed, connected world that we are going to live in, and we are already living in it, if everything is homogeneous, it is like a monochromatic picture with no color. There is no diversity to it. There is no interest to it. So one of the things that we as technologists, as well as management people and social scientists and ethnographers, we all have to work together to figure out is how do we create an interconnected world where somehow we allow individual pockets to retain their diversity and their own independent culture. And I will just stop by saying that one question that I always come up with is, what would Gandhi have said? How would he approach this problem? Because to me, he always was and remains one of the idols in my life. And one thing that I have started thinking about is, maybe when Gandhi talked about the notion of an ideal village, if you read any of his writings, Gandhi always talked about Adarsh Gamdu. That was his concept, Mara Swapnanu Bharat, India of my dream. He talks about how he views India as a collection of these ideal villages that retain, they are independent, they are self-governed, they retain their own culture, but at the same time, they can function in the larger context. So the idea that I would like to figure out is maybe if we could work together to create these virtual villages where individual communities can operate within their own self and have their own cultures and rituals and all those things, but at the same time, it allows them to participate in the global world. And this would require a lot of us to invest differently, A lot of us have to invest to retain these cultures rather than letting these individual heterogeneity aspects kind of dissipate in this larger global world. And that's the challenge that I would just like to pose to all of you, that as you become more involved in the field of technology and try to push towards these new boundaries, let's think about how do we retain that diversity and that heterogeneity, which makes our own personal life experience richer and more meaningful. So with that, I'll stop. Thank you very much for your time.